Hi guys and welcome back. So in this video we're going to be doing problem 3 from the first signals recitation, and the problem is this. We're given a sum of complex exponentials, and we're really given, I shouldn't say that, we're just given a function. We're given a function x of t. Let me write down what that function is. It is 1 minus 2j times e to the j 3t plus 1 plus 2j e to the minus j 3t. And what we're supposed to do here is we are supposed to figure out what, if we wanted to write this as cosines, or a sum of cosines, or however many cosines this is, pretty much do that. Write this as a cosine, or if there are more than one cosine, a sum of cosines. So anyway, that's the problem, and if you want to do it, now's a great time to pause the video. And now I'm just going to keep going. So first off, this is only one cosine. We only have one omega here by inspection. And remember that what we're going to be using here is if I have k cosine omega t plus phase, I can write that as k over 2 e to the j phase e to the j omega t plus k over 2 e to the minus j phase e to the minus j omega t. If you want to see where this comes from, watch the video for problem 19. I go all through how to get this. So now, what we can do here is we can say, okay, we can sort of obviously see what our omega is, right? Because we have this j3t minus j3t. We can almost obviously see just by inspection our omega is going to be 3. But we don't necessarily have our phase information. We don't have it explicitly because we have a complex number here, but this is in rectangular form. So really what we have to do here is we have to convert this into polar form, and then we're going to really quickly have something that we can use, have something that's in the form magnitude times e to the j phase. So now what we have to do, we have to get our magnitude, which is 1 squared plus 2 squared, take the square root. And so 1 squared is 1, 2 squared is 4. This is the square root of 5. That's our magnitude. And now we have to figure out our phase. So our phase here, and remember this is 1 minus 2j, so if I drew my real and imaginary axes, this is real, this is imaginary. I have positive real, negative imaginary. It's going to fall in the fourth quadrant. So if I want to get my phase, I just have to do arc tangent of my imaginary part, which is minus 2, divided by my real part, which is 1. I don't have to add pi to this number. This just immediately gives me my phase. So now I get the calculator out. There we go. So minus 2 divided by 1 is just minus 2. So it's 2 minus, take the arc tangent of that, and I get minus 1.1071. This is equal to minus 1.1071. And so now I know that I can rewrite this x of t as x of t is equal to the square root of 5. And even here, I'm going to rewrite this as the square root, as 2 square roots of 5 divided by 2. I'm just going to go ahead and write it like that. I'm just multiplying it by 1 here. 2 square roots of 5 times e to the j phase, which is minus 1.1071. And then e to the j omega t, which is e to the j 3t. And then I just add on to that pretty much the complex conjugate of that whole thing, right? Because these two, this is the 1 minus 2j is the complex conjugate of 1 plus 2j. So I don't have to like convert this number over again from rectangular to polar form. I can just say, hey, these two are complex conjugates, so that means that that number has got to be 2 root 5 over 2 times e to the j positive 1.1071 e to the j 3t. And now I've got something that's explicitly in the form that I can convert this. And even I want to say I didn't even have to do this second part. I didn't even have to do the complex conjugate because I already have all the information I need. I know that my k over 2 is equal to 2 root 5 over 2. The over 2's cancel, so my k is just equal to 2 root 5. I can tell that right from here. I know that my omega is equal to 3. We could tell that before we even really started doing anything with this problem. And I also figured out that my phi, my phase, is equal to minus 1.1071. I didn't even have to continue on writing out what the cosine was as a sum of complex exponentials. I can just take this information and say that my x of t function is equal to 2 square roots of 5 times the cosine of 3t minus 1.1071. So hopefully you followed that. I know I might have gone through that a little bit fast. There are a couple of more videos where we do similar stuff. But anyway, hopefully this made sense to you. Hopefully you found it useful. This is the answer, by the way. X of t is 2 root 5 cosine of 3t minus 1.1071. Hopefully you found that useful, and I'll see you in a future video.